we're going to look at area and surface area and what are the differences between those two. And we're going to do that by looking at an example. So our example says find the area of a piece of sheet metal that is 36 inches by 120 inches. So let's start with sort of drawing a picture of what that represents. So we have a piece of sheet metal, and it is 36 inches by 120 inches. And we would like to know what the area of that piece of sheet metal is. So remember, area is a squared unit inside a two-dimensional shape. And generally we can look up formulas associated with these. So if we go to our resource sheet and we look at our area formulas, so we're dealing with a rectangle. So the area of a rectangle, the formula is given as length times width. So let's apply that to our actual example. So we are going to look at the area of this particular sheet metal, which we know is length multiplied by width. So our length given in the question is 36 inches, and our width is 120 inches. So 36 times 120, we put that into our calculator, and we end up getting 4,320 in a numerical sense, but we always want to be thinking about our unit. So in the area situation, we're doing inches times inches, so we end up getting inches squared in the end. So that piece of sheet metal, in an area sense, is 4,320 inches squared. In general, we wouldn't quote maybe a number that is in that relationship. More commonly, we might use something like feet squared. So recall, a common unit conversion factor for area is that 1 foot squared is equivalent to 144 inches squared. So remember that 1 foot is equivalent to 12 inches, which means if we're looking at a squared unit, we have to make sure we square everything. So 1 foot squared is equivalent to 144 inches squared. So let's do a conversion of our area in inches squared, and we'll convert that to feet squared. So 4,320 inches squared, all divided by 144 inches squared. Inches cancels out, and when we do that division, we end up getting 30 squared feet coming out. And again, it would make more logical sense to sort of talk about 30 squared feet instead of maybe 4,320 inches squared. So our next part of the question says, well, what happens if we take that sheet metal and we fold it up and create a duct from it? So there's different ways, obviously, that we can do that. The way that I'm going to do it is I'm going to cut basically this 120 into groups of 4, or into 4, and so we're going to actually have 30 inches, and we're going to fold this ductwork together. So I'm going to take a two-dimensional shape and create a three-dimensional shape from it. So now we're saying, now we have a duct. So now three-dimensional shape, and we've actually taken that ductwork and we folded it over. Sorry, that sheet metal, we folded it over. So now we have 36 inches, still as sort of our length sense. And then this whole part adds up to 120, so each of those parts is going to be 30 inches, 30 inches, 30 inches, etc. And so if we look at the actual metal, that's all sort of around the outside. So we're leaving two sort of gaps at the end. So that hasn't actually changed. So no matter whether we have that as a two-dimensional shape or a three-dimensional shape, our area is still equivalent to 4,320 inches squared, or 30 squared feet. So we can be looking at that regardless of whether it's a two-dimensional shape or a three-dimensional shape. Once we actually create it as a three-dimensional shape, we no longer really use the term just area. We actually now call this lateral surface area. So once we've created a three-dimensional shape from a two-dimensional shape, we're now looking at its surface area. So the area around the particular shape, still looking at an area sense, but we call this lateral surface area. If we actually take the time and we close off these ends or these bases on each end, so we are actually creating a box, so we're closing off the ends, then we're actually adding a few more areas. So we're adding to area of the base, or what we call the face, associated with it. And if we do that, we're actually creating our total surface area. So one of them just looks at area around a shape basically without looking at its base ends. And if you actually add those base ends to it, we talk about it being total surface area. So there are a couple definitions associated with it. Lateral surface area, sometimes used LSA, is the area of all the surfaces excluding the bases, and it is measured in square units. Total surface area, or TSA, is the area of all surfaces including the bases, and it's also measured in square units.